Hello, sixth graders. Welcome to Science with Mr. Burner. I'm going to walk you through part one of your matter investigation extension. So bear with me, and we're going to walk through these three different science experiments. Let's do it. All right. So the first thing that we're asked to do is we're going to weigh an index card. We're going to see how much mass it has. And we're going to rip it up. We're going to crumple it up. We're going to tear it up. We're going to teach this index card a lesson, and then we'll see if the mass changed, if it stayed the same. All right, let's see what it weighs before I rip it up. All right, so I have 1.2 grams weighed out. So I'm going to go ahead into my data chart back here, and I'm going to record 1.2 grams as the mass before change. All right, so we know that it weighs 1.2 grams before we change its state. Now, let's teach this index card a lesson. All right. Let's throw it back on the scale. Let's see if the weight or the mass has changed. Oh my gosh. 1.2. All right, we're going to record that in our data chart. 1.2 grams. All right, so if the mass is 1.2 before we change the state of matter, and it's 1.2 after, is matter conserved? You are correct. It is conserved. We didn't lose any matter. We didn't create any matter. So again, it will be conserved. So I'll put a Y here for yes. All right, so that's going to be our first little experiment here. All right, so for this next one, we're going to see when a glass of ice water melts. We know that ice changes from a solid to a liquid. So we're going to again test to see if ice water, once it melts, if the matter changes. Let's find out. Give me one sec. Let me pour a glass of water here. All right, I'm going to fill it up with some ice. All right, got a nice glass of ice water right here. Let's throw it on the scale. Let's see how much it weighs before that ice melts. All right, so I'm sitting here at a cool 833 grams. That's what I'm going to go ahead and record in my data chart. $833 grams. So I'm going to let that sit. I'm going to let that ice melt, and we'll come back in a few minutes, and we'll see once the ice is melted whether matter was conserved, whether the mass changed. Alrighty. So we'll set that aside for now, and we'll come back in a minute, and we'll see once that ice melts whether the mass changed. All right. For our third experiment, we're going to be mixing Alka-Seltzer and water. So this is going to produce a chemical reaction. So when the Alka-Seltzer mixes with the water, it's going to create some fizzy bubbles, and we're going to see another phase change. So let's check it out. Again, I will have to pour another glass of water. All right. So what we're going to do here is first we're going to weigh our Alka-Seltzers. We'll weigh our water. We'll add them up, and that'll give us our starting mass. All right. So if I put 2 Alka-Seltzers on the scale here, oops, it turned off. All right, so I'm going to throw 2 Alka-Seltzers on the scale here. All right, so that gives me a starting weight of 6.5 grams. So I'm going to keep that 6.5 in my head, and I'm going to add it to whatever the mass of this glass of water is. All right, 452.5. So if I add those numbers up, that's going to give me a starting mass of 459.0 grams. So I'm going to go ahead and I'm going to record my starting mass. And again, that's 459 even. Oh yeah, 459 grams. All right. Let's take this off the scale here. Let's add my Alka-Seltzer, and let's see what happens when they combine. Kobe. All right. Zoom in on this. All right, so we can see some fizz. We can see some bubbles starting to escape. Maybe you can't see it very well, but the Alka-Seltzer and the water, they are reacting together and they're producing bubbles. So gas is traveling up through the air. So we'll let that sit for a minute. We'll let it do its thing. So again, as you can see, it's kind of like when you open a bottle of soda, all that fizz is starting to escape to the top. So we'll give that another second. It's almost done mixing. All right. So our chemical reaction has occurred. The Alka-Seltzer has mixed with the water. So again, I'm going to throw it on the scale here, and I'm going to check out what the mass is. Dang it, it turned off again. Dang scales. All right. Oh, so it's a little bit different. So for this one, I got a cool 457 grams. All right, so we know that matter cannot be created or destroyed. So what happened to those other 2 grams? I'll let you think for a second, and then I'll give you the rundown. So take a few minutes, brainstorm. All right, I'll tell you. So those other 2 grams that have seemingly gone missing simply just escaped as gas. So if we see right here, all that little fizz coming up, all these little air bubbles that are escaping, matter isn't being destroyed. It's simply just converting into a gaseous state. So it's turning into gas. So 2 grams from that 459 grams turned into gas. So we know matter wasn't destroyed. It simply just changed form. So we're going to go on here and we're going to mark yes, matter was conserved, because again, 2 of those grams simply just escaped as gas. All right. Looks like our water's just about melted here. Let's check up on it. Let's see if the mass has changed at all now that the water is melted. Wipe off my scale here. All right. All right, let's check the mass of our water glass. So it started off at 833, and we know that ice melted into water. So now we have just about, let's say, full glass of liquid. Let's put it on the scale. Let's see if it's changed. 833. All right, so I'll go record my mass after change. So the mass before the change is the exact same mass as after the change. So again, was matter conserved? Right again, kids, it was. All right, that's going to conclude my little demonstration for part 1. I hope you all enjoyed that. All righty, keep working on it.